The function we're going to work with in example 3 is f of x is equal to negative 2 times x squared plus 2 times x minus 3. Okay, so for this quadratic function, we will do what we've been doing. We will compute the vertex, find the x-intercepts and the y-intercept, write down the axis of symmetry, use all of that information to draw the graph of the parabola, and then write down the domain and range of the parabola and write down the intervals of increase and decrease, and finally look at a quadratic inequality involving this particular function. Okay, so let's get started. Again, let's look at the function and say, hey, why is this quadratic? Well, when you look at it, it fits the mold of f of x is equal to a times x squared plus bx plus c. Okay, the highest power of x in the whole thing is the second power. Let's go ahead and identify the a, the b, and the c. So a is the number in front of x squared, so it's negative 2. B is the number in front of x, it's positive 2. And then c is the constant, so it's negative 3. And now let's start finding the vertex. Okay, so again, the vertex is going to be the central point of the parabola. So it's going to be an ordered pair. So to find the x-coordinate of the vertex, we're going to use the vertex formula. That tells us that x is equal to negative b over 2a. So we just identified the a and the b above. So all we have to do is plug those values in. So let's do it. So in the numerator, we're going to have negative b. Okay, so negative, that's part of the formula. And then b is 2. Okay, and then in the denominator, we're going to have 2 times a. A is negative 2. Okay, so always be careful with your signs. This is going to be negative 2 over negative 4. Negative divided by negative will be positive. So positive 2/4, which reduces to 1/2. Okay, so there you go. That's your x coordinate. Now we need to get the y coordinate. So to get that, we have to take this x value and we need to plug it in to the original function. So let's go ahead and do that. If you want, since this guy is a fraction, remember 1/2 is the same thing as 0.5. So that might be easier not only to, work with when you're plugging in for x, but it's also going to be easier when you're graphing. Okay, so let's go ahead and look at the decimal version of this. Okay. All right, so now let's plug in x equals 0.5 into the original function. Before we do that, let's go out to the side here because we've got some negative signs involved, so let's make sure we know how to handle that. So if I break down the function here, f of x is the same thing as y. We've got negative 2 times x squared. X squared is x times x plus 2 times x plus, or sorry, minus 3. So negative 2 times x plus 2 times x minus 3. Okay, so here it's broken down. You don't have to deal with the exponents. Please do that if that helps you. Okay, so if we plug into that, we're going to get negative 2 times x. So it's going to be negative 2 times x, which is 0.5, times x, which is 0.5. And then we will have plus 2 times x. So plus 2 times 0.5. And then you have your minus 3. Okay, so if you want, you can just pop this into a calculator. So let's do that. Okay, so we're going to get negative 2 times 0.5 times 0.5 plus 2 times 0.5 minus 3. Okay, so you get a nice decimal. It's just negative 2.5. If you want to change it into a fraction, you can, but remember, we're going to have to graph the vertex. It's a lot easier to understand negative 2.5 than it is negative 5/2. Okay, so it's a lot easier to find on the graph if you're dealing with the decimal version. Okay, so I'm just going to go back to my notes and write down the decimal version. The y value here is going to be negative 2.5. Okay, all right, so your vertex here, the x coordinate is going to be 0.5 and the y coordinate is going to be negative 2.5. Okay, if we go ahead and graph that, you're going to have to kind of estimate it. If you're looking for the x coordinate of 0.5, that's halfway between 0 and 1. So if you look where my cursor is, 0.5 on the x-axis is right here, and then the y coordinate is negative 2.5. So you're going to have to go in the negative direction, and you're going to have to go halfway between negative 2 and negative 3. Okay, so it's about right there. Okay. All right, so now let's deal with the x-intercepts. Okay, so on examples 1 and 2, both times I promised you that I would use a quadratic formula, and I totally forgot. So I will try it on this one. This particular function, you could try to factor it if you wanted to. It looks kind of nasty, like the numbers aren't very nice, the a, b, and the c. So you may just want to jump to the quadratic formula. Do that at first instead of trying to factor. Okay, we haven't talked about the quadratic formula yet in this class. Okay, so on the last page of this packet, so if you jump to page 6 at the very bottom, I have the quadratic formula written down for you. Okay, so remember, the quadratic formula always works if you're trying to solve a quadratic equation. Okay, so if you read what's in the box, this should be a refresher for you. The solutions to the quadratic equation: a times x squared plus b times x plus c is equal to 0, where a is not equal to 0, are given by the following. Okay, your x values, your solutions are going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, keep in mind when you work with this formula, the entire numerator is divided by 2a. Okay, not just the negative b, not just the square root, the entire thing. Okay, all right, so let's go back and take a look at this. Okay, so I'm going to write down the quadratic formula. Okay, well, hang on a second before I do that. If we're finding the x-intercepts, let's talk about why we need the quadratic formula. If we're finding the x-intercepts, remember, we have to set y equal to 0 and solve for x. So if you go to the original function, okay, f of x is y, so if you set y equal to 0, you have to solve the equation negative 2x squared plus 2 times x minus 3. Okay, so we're solving a quadratic equation. Like I said, the a, b, and c are not very friendly, so we're just going to use the quadratic formula on this. Okay, the quadratic formula, we just saw it. It is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, the a, b, and c are exactly what we identified above. Okay, a is negative 2. It is always the number in front of x squared. B is always the number in front of x, so it's 2 here. C is always the constant. It's negative 3 in this situation. Okay, so if we just plug in here, and this is going to give us the solutions to x, the values of x that make this a true statement. Okay, we're going to get the following. Okay, so negative b, that's going to be negative 2 plus or minus the square root of b squared, so that's going to be 2 squared, minus 4 times a, which is negative 2, times c, which is negative 3, all over 2 times a. A is negative 2. Okay, this is how you plug into it, and then you have to simplify. All right, so let's see what we get. Okay, let's work in the numerator. We're going to get negative 2 plus or minus, let's see what's under the square root. Under the square root, we're going to get 4. 2 squared is 4. And then we've got minus. Okay, that's this minus right here. This goes here. Okay, and then we've got 4 times negative 2, that's negative 8, times negative 3 is going to be positive 24. Okay, so when you look at this, okay, let me do this one more time. 2 squared is 4. Okay, the yellow minus sign goes down here. Okay, and then if you do 4, positive 4 times negative 2 times negative 3, you're going to get positive 24. Okay, so underneath the square root, you have 4 minus 24. Okay, in the denominator, you have negative 2. Okay, if you keep going here, okay, in the numerator, you're going to have negative 2 plus or minus. Under the square root, you're going to have 4 minus 24, which is negative 20. Okay, you'll still have negative 2 in the bottom. Okay, So as soon as you do this, okay, you should hear an alarm bell going off in your head. You have a negative under the square root. We cannot ever take the square root of a negative number, okay? So I'm going to go ahead and circle this, okay? This is bad, okay? We can't have a negative under the square root. All right, so what does this mean? Okay, well, think about what we were doing. Okay, we were trying to find the x-intercepts of this parabola. Okay, so we set up our quadratic equation. So that was negative 2x squared plus 2x minus 3 is equal to 0. And we started trying to solve it. Okay, so along the way, we ran into a big error. You can't take the square root of a negative number. Okay, so what this means, since we ran into a problem, this means there are no x-intercepts. Okay, the parabola will not intersect the x-axis at all. Okay, all right, so going back to our picture, all we have is the vertex. Okay, so, you know, we got to keep going. We've got, this parabola looks like something. Okay, so let's go take a look at the y-intercepts and see if that, at the y-intercept, and see if that tells us any additional information so that we can see what this parabola looks like, but there aren't any x-intercepts. Okay, for the y-intercept, okay, we need to set x equal to 0 in the original equation and solve for y. Okay, so if we scroll back up to the original equation, either the yellow version or, you know, this version right here that I'm circling where we broke the exponents down, it's up to you. So I'm going to go with the yellow version. Okay, if we plug in x equals 0, we're going to get negative 2 times 0 squared plus 2 times 0 minus 3. Okay, so let me make sure that's right. Yep. And so this will simplify. 0 squared is 0 times negative 2 is going to be 0. Okay, plus 0 minus 3. So this is going to give us negative 3. Okay, so as an ordered pair, the y-intercept is going to have an x-coordinate of 0 and a y-coordinate of negative 3. Okay, so we can surely plot that. Okay, notice here is 0, negative 3. It's extremely close to the vertex. Extremely close to the vertex. Okay, so I'll even make a note over here. So far, we know 2 points on the graph, the y-intercept, which is 0, negative 3. And we also know the vertex, which has coordinates 0.5, negative 2.5. Those 2 points are so close together. Okay, so at this point, we need a third point on the parabola. Okay, how do we get it? Okay, we've already run through the work for the vertex and the x-intercepts and the y-intercept. What else do we do? Because we've only got 2 points. Well, remember the trick we learned in one of the prior examples. Okay, you can use the axis of symmetry. Okay, so if I draw in the axis of symmetry, it is the vertical line through the vertex. Okay, so I'm drawing it in as this green dotted line. Okay, the parabola is going to have to be symmetric about this vertical line. Okay, so when you look at the y-intercept, it has coordinates 0, negative 3. So it is located 0.5 units to the left of the vertical line. So that means if you were to fold your sheet of paper along this green dotted line, the point over here, this point right here, it is 0.5 units to the right of the vertical line. It also has to be on the parabola. Okay, so this point that I just drew in, it has coordinates 1, negative 3. Okay, so because of this symmetry, because the parabola has to be symmetric about the axis of symmetry, that point will be on the parabola. Okay, so now you've got your 3 points. Okay, and it seems like you've got a downward opening parabola. Okay, and this is a really tiny parabola, but this is what it looks like. Okay, if you go back up to the formula, okay, we forgot to talk about this, but the a value is negative. So we, should have expected a downward opening parabola. That's what we got. And remember, the vertex is going to be the highest point on the parabola. Okay, All right, so we've got our picture. Okay, so now let's write down the domain and the range. Okay, domain, you know, the function is a polynomial. When you look at the graph covers the entire x-axis because the parabola keeps going down, 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 down forever. Okay, so anytime you're working with a parabola, the domain is always all real numbers. Okay, range is a different story. Okay, we need to look at our y values. We need to go from the lowest y value to the highest y value. So since the parabola goes down, 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 down forever, the lowest y value is going to be negative infinity. And then the highest point on the parabola is the vertex, which has coordinates 0.5, negative 2.5. So the highest y value is negative 2.5. Okay, that is a closed circle at the vertex, so we want to include negative 2.5 in the range. Okay, all right, let's talk increasing and decreasing. Okay, so remember the axis of symmetry is kind of a dividing line. On one side of the axis of symmetry, the parabola is either increasing or decreasing, and then on the other side of the axis of symmetry, it's doing the opposite thing. So let's start traveling the parabola from left to right. All right, so if we start at the leftmost point, we're rising. So we're increasing until we get to the vertex. And then once we hit the vertex or the axis of symmetry, we start falling. Okay, so then after that, we are decreasing. Okay, so now we can kind of write the intervals of increase and decrease down. Remember, when you state increasing and decreasing, you have to state the x values over which this is occurring. Okay, so if you look at the yellow portion of the parabola, okay, that yellow portion exists for x values less than, well, what is the vertex? Okay, it's the negative x values up until the vertex. Okay, well, the vertex has an x coordinate of 0.5. Okay, so you're increasing to the left of the vertex, or to the left of the axis of symmetry. So you're increasing over negative x values up until x equals 0.5. Okay, and then on the other side of the axis of symmetry, or the other side of the vertex, you're decreasing. So you're starting at the vertex that has an x coordinate of 0.5, and then after that, okay, over positive x values, you're decreasing. Okay, so that's that. Okay, I did forget to write down the axis of symmetry. I always forget that because there's no work required. If I had to write down the equation of this green vertical line, okay, I'll go ahead and do that up here. So remember, since it's a vertical line, the equation is going to be x equals, and all you have to do is write down x equals the x coordinate of the vertex. Okay, the x coordinate of the vertex here is 0.5. Okay, so this is it. That's it. All right, so every point on this green dotted line has an x coordinate of 0.5. All right, so jumping ahead to kind of preview what's going to happen in section 4.5, let's take a look at this quadratic inequality. Okay, in part C, it says, for what values of x is the following statement true? Where is negative 2x squared plus 2x minus 3 less than 0? Okay, so again, when you look at this, for what values of x, the answer must be x values. Okay, now we're going to try to translate the inequality. It's an inequality because it's got a less than symbol. Okay, if we look to the left of the less than symbol, we've got negative 2x squared plus 2x minus 3. That is exactly our function, our f of x. Okay, so if you look up here, that's what f of x is. Okay, so if you go back down here, okay, we know this is f of x, so you can translate this inequality. Okay, we're trying to figure out when is f of x less than 0. Okay, and then you can translate f of x. This is saying when is y less than 0. Okay, so what are we trying to write down? We are trying to write down the x values that have negative y values. Okay, because You're trying to figure out when y is less than 0. So when is y negative? Okay, so we know just from working with graphs that negative y values occur below the x-axis. Okay, so you need to go up to your picture and you ask yourself, okay, where is the parabola below the x-axis? And the answer is everywhere. Okay, so for every single x value, like for example, if I pick a random x value, -4, okay, if I look at the corresponding y value, it's negative. If I pick another random x value, 6, okay, the y value is way down here, it's negative. Every single x value has a negative y value, okay? So the answer is all values of x, okay? So that's going to be all real numbers, okay? That's the answer, okay? If I had instead asked you, and I'm going to kind of change it up, so I'm going to put it in a different color here. So if I had kind of turned the tables on you here, okay, and I asked you instead, let me see if I can get this thing to do this. Okay, if I asked you instead, when is negative 2x squared plus 2x minus 3 greater than 0? Okay, so I would still involve the same function here, okay, but now I'm figuring out when is f of x bigger than 0, so when is y bigger than 0. So if I flip the inequality symbol on you and I just switch from a less than to a greater than, okay, this would be asking, you know, this would be asking you to write down the x values that have positive y values, okay? Positive y values happen above the x-axis, okay? The parabola is never above the x-axis. No part of it is above the x-axis. So that never happens because every x value has a negative y value. So if we had instead looked at this inequality, it would have no solution, okay? But as it was written, okay, the answer was all real numbers.